is a distant blue marble, and we're finally arriving. Picture a sleek silver colony ship touching down on alien soil. We've all seen the movies and heard the billionaire pitches about moving humanity across the solar system. But packing up for the Red Planet requires a grueling 1,000-day journey through an incredibly hostile void. As soon as a crew leaves the protective bubble of Earth's atmosphere, they face severe physical threats. NASA actively classifies 5 main hazards for human spaceflight, ranging from altered gravity fields to extreme isolation. Galactic cosmic radiation easily bypasses spacecraft shielding, which locks only 7 to 15% of deep space particles. This exposure is severe. A 1,000-day Mars trip increases an astronaut's lifetime cancer risk by 33%, drastically exceeding the 0.5% annual limit for Earth's nuclear plant workers. Our bodies evolved for the specific, protected environment of Earth. Long before a crew ever spots the Martian horizon, the deep space environment breaks down their biology. The external radiation is accompanied by severe internal physical decay. This visual progression of a human femur shows exactly how the internal structure loses density over time. On a standard journey to Mars, prolonged weightlessness causes astronauts to lose between 15 and 22% of their bone mineral density. If that mission stretches out to 3 years, they lose an entire third of their bone mass. Without gravity constantly pulling on our skeletons, the human body assumes it no longer needs a heavy reinforced frame. The bone maintenance system simply shut down. If a colonist steps onto the Martian surface and suffers a simple fracture, it becomes an absolute catastrophe. They are at least a full year away from any proper medical treatment back on Earth. Building a massive, reusable rocket is a solved engineering problem. Preserving the fragile human skeleton inside that rocket is the true barrier to long-term colonization. When a crew arrives, they step out onto an unimaginably hostile world. This landscape view of the rocky Martian surface under a pale orange sky represents an environment where colonists will spend nearly all their time trapped indoors or deep underground. The atmospheric pressure outside is roughly 1% of Earth's. There is no magnetic field, meaning solar winds strip away what real atmosphere remains, making the surface deadly to unprotected humans. To test the psychological toll of that extreme confinement, researchers run deep isolation simulations right here on Earth, putting 6 people inside a nearly windowless white dome on the slopes of a Hawaiian volcano. To survive the crushing boredom of a tiny enclosed base, these crews actively manufacture their own microcultures. They invent ridiculous holidays and put on elaborate theatrical skits to break up the monotonous routine. Keeping the mind entertained prevents crews from turning on each other. Cultural engagement acts as a mandatory psychological survival tactic in deep isolation. Even if a colonist maintains their sanity, their body still has to cope with a physical environment operating at 38% of Earth's gravity. We have a historical point of reference for this. Looking at this astronaut standing near a lunar module leg, a person on Mars would feel twice as heavy as Neil Armstrong felt navigating the moon. For fully grown adults, the mechanics of a simple walk transform completely. Every single step becomes a rhythmic, bouncy glide. The real biological test begins with the colonists who intend to stay. A child born and raised in that 38% gravity will develop entirely differently than their parents. Their skeletal structure and cardiac muscles will optimize exclusively for a low-gravity world. They may never build the physical strength required to endure the heavy, punishing gravity of Earth. The first generation born on Mars will be permanently bound to their new planet. Their physical biology will forever tie them to the Red Canyons, making a trip back to Earth impossible. Sci-fi movies love the grand idea of terraforming, using giant orbital mirrors and thickening the atmosphere to eventually make rivers flow again over thousands of years. A much more scientifically grounded proposal involves building massive, localized environments. We'd construct vertical human cities tucked safely inside ancient lava tubes, or enclosed completely under massive 500-meter-high glass ceilings. As we plan these massive colonial expansions, the astrobiology community is raising urgent red flags regarding the ethical cost of our arrival. Researchers argue strongly against repeating historical practices that treat Mars as terra nullius, completely empty land ready for unrestrained resource mining and extractive capitalism. This global map illustrates the absolute most severe threat: global biocontamination. Microscopic terrestrial spores brought by human explorers could easily be picked up by the winds and rapidly distributed all across the planet. If there is any microscopic life currently existing in the Martian soil, our presence could contaminate it irreversibly. We would destroy our one and only chance to study an independent genesis of life. Surviving this frontier requires radical physical and psychological adaptation, along with a strict moral framework. Humanity will have to evolve to live on Mars,